Alright, hello everyone. This is our first flipped classroom notes video, so please follow along carefully and fill in the work that I am doing. So first put your name at the top and today's date. Alright, so we are going to start out talking about distance and midpoint in geometry. So to study the distance, we are going to use something called the Pythagorean theorem. You might have recognized this, you might have learned it before, but if not, that is okay. Our Pythagorean theorem states that a squared plus b squared equals c squared. So this is talking about the sides of a right triangle. We're going to see this later in geometry. And our sides here that we need to label, the legs and the base are A and B. And then the long slanty side, called the hypotenuse, is C. So the hypotenuse is always C. In this unit, the distance that we're looking for, it might be A or B, but it is more often than not going to be C. So we will use the Pythagorean theorem. So here's just a quick example of the Pythagorean theorem and how that works with some numbers in the example. So if I have 3 squared, I'm going to fill this in for A, and then 4 squared for B, and 5 squared for C. So 3 squared, if I type that in my calculator, remember there's that little exponent button over to the left. 3 squared gives me 9, plus 4 squared gives me 16, equals 5 squared, which is 25. And then if I add 9 plus 16, I see that 25 equals 25. So that's how that works. Alright, so let's talk about distance and length. Distance and length. So distance and length is the measurement of a line segment. Something super important that I want to point out is that distance is always a positive number. If you walk to school, or maybe you take the bus, or maybe you ride in a car, do you go negative miles to school? No, I don't think so. You can't travel in negative miles. You travel in positive miles. Whenever we travel, the distance is always positive. So let's try some examples over here on a graph. So I have my 2 points right here, and I'm just going to connect the line segment in between them. And now I need to measure the distance. So since this is just a nice straight line, I'm going to go ahead and count the spaces between them. So if I move my pen over 1, 2, 3, 4, 5, 6. So I see that from my first point to my second point, the distance is 6. And all I had to do was count. If I look at this example though, and I connect the line between these points, does it look like I can easily just count the units between them? Because if you look at it, this line is passing through all the little middle parts of the grid, and so it's not on even points. What I can do is use the Pythagorean theorem that we learned up here. So I'm going to just drop a line down from here until I get to the point where this point is on the same level. And then same thing, if I just drop a line over here, I'm going to run into that. And now you see I have this nice right triangle, just like we had up here. So if I count my orange side right here, I have a distance of 1, 2, 3, 4. So the orange leg is 4 units. If I count this purple leg here, I count 1, 2, 3, 4, 5. And now remember, I'm in a negative part of my graph, but we said that distance is always positive, so I'm going to leave these numbers positive. So now that I have these 2 leg measurements, and I'm looking for this pink piece, I'm going to label that pink piece C from my Pythagorean theorem, and now I can use my theorem to solve it. So I'm going to plug in 5 squared for A plus 4 squared for B equals C squared. If I grab my calculator, I see that 5 squared gives me 25, plus 4 squared is 16, equals c squared. Now I add 25 and 16 to get 41 equals c squared. And then we talked about this last week. The opposite operation of squared is square root. So I'm going to take the square root of each side. At this point, you can leave your answer as c equals the square root of 41, or you can type that in your calculator and get a decimal of 6.4. So you can choose to leave the square root, the final square root, or you can type it in to get the decimal. All right, we're going to do one more example of this all together, and then we will move on. So find the distance between point A and B. So hint, I'm first going to plot the points. So A, I move to the left -2, and up and down 0, so I just stay right there on the axis. And then for B, 6, -4, so I count to the right 6, and then down -4. I have my point right there. So I label my points, and now I'm going to connect a line between them. I notice here that this line is not an easy one to count on the graph, so I am going to have to use my Pythagorean theorem. So I'm going to drop a line down there and count my purple line as 1, 2, 3, 4 units. Now I'm going to draw a pink line over here and see that this is distance of 1, 2, 3, 4, 5, 6, 7, 8. So I have the two legs of my triangle and I need to find C, so I can use my Pythagorean theorem. 4 squared gives me 16, plus 8 squared is 64, equals c squared. 16 plus 64 is 80. And now I can take the square root of each side. So again, I can leave my answer as c equals the square root of 80, or if I type that in my calculator, I get 8.9. Oops. There you go. All right, if you want to go ahead and flip your paper over, we are going to talk about midpoint. So we've found the distance between segments, but what if we want to find the middle, the midpoint? So the midpoint is the point in the middle of 2 points. Now it's not just any point in the middle, it's the point that is exactly in the middle of 2 points on the graph. And midpoint is always, always, always a coordinate point. So midpoint is not asking for a value like distance. Our answer is always going to be a coordinate point for midpoint. So if we look over here at these examples, I can find the midpoint of these line segments. So if I count this line segment, I see that it is a distance of 1, 2, 3, 4, 5, 6. So that is 6 long. But if I want the middle of that point, I can count in from each side. So if I know that 6 divided by 2 is 3, I need to count 3 points in from each side. And that's going to leave me at the midpoint right here. But my answer is not 6. My answer is not 3. My answer is what the actual point is. So if I look at this midpoint right here, I see that it is at -3, 4. There we go. We look at number 2 here. I'm going to count the total distance. 1, 2, 3, 4, 5. Uh-oh, this is a little bit of a tricky one. If our total distance is 5, 5 divided by 2 is not a nice even number. It's going to give me 2.5. So I'm going to do my best here to estimate. I count 1, 2, I'm going to count in the middle of that last one since I know it is 2.5. And then the same thing from the other side. So I can put my point right there in the middle. And now I need to find what the coordinate is at my midpoint. So I move my pen over to -6. And then since we said the middle was at 2.5 between each side, if I'm over at 6, it looks like I need to move down by 0.5. And since I'm moving down, it is negative. All right, let's make it a little bit trickier over here. How would I find the midpoint of this? Well, I don't really know what the distance of it is because it's a slanty line, so that's going to be a little bit trickier. So there are two different ways that I could solve this problem. So let's try the first way using the picture. So I'm going to see that this is a slanty line, and I'm going to drop my sides like I did with the Pythagorean theorem on the front. So if I look at these two sides, I see that this orange side here has a distance of 1, 2, 3, 4, 5, a total distance of 5. And then this pink side here has a total distance of 1, 2, 3, 4. Well, if I want to find the middle on this line, I just need to find the middle of each of these lines. So the middle of 4 divided by 2 is going to give me 2. So I move 2 down this line, and I'm going to draw a dotted line over to here. Same idea with the 5. 5 divided by 2 is 2.5. So I move over 2 and my extra 0.5. I'm going to draw a little dotted line up here. And where these two dotted lines run into each other, we have our midpoint. That looks like it's a little bit hard to estimate though from the picture. So I'm going to go ahead and introduce our midpoint formula. So if you're not a visual person and would rather have a formula, here it is. So if we have 2 points, A, comma, B, and C, comma, D, and we want to find the midpoint between those points, my formula is A, so the x value plus the other x value, divided by 2, since it is in the middle, and then B, my y value, and my other y value, D, again, divided by 2, since we are looking for the midpoint. So let's go ahead and try to use that over here. So for number 3, first I need to find what those two endpoints were so that I have these 2 points to begin with. So it looks like my endpoint over here is at 6, comma 1. And my endpoint up here is at 1, comma 5. All right, so I have my 2 points, and I'm going to use my midpoint formula. So I take my first x value plus my second x value divided by 2. So I have 1 plus 6 divided by 2. And then I need my y values, so I have 5 plus 1 divided by 2. And then if I do the math here, I have 1 plus 6 gives me 7 divided by 2, and 5 plus 1 gives me 6 divided by 2. And if I type those in my calculator, I'm going to go ahead and get 3.5, comma 3. If we look back up here at the visual method that we did earlier, you'd see that if I move over 3.5, that was the middle here, and then if I moved up 3, that was the middle. So you can still use this visual method, but if it's not a nice even number, like 4 was a nice even number but 5 is not, then this might be the easier method so that you're ensuring you're not making a mistake. All right, let's do one more example all together, and this will be the end of the notes. So let's find the midpoint between points B and C. So first I need to graph them. So B, I move to the left -2, and up positive 3. And then for C, I move to the right 3 and up 5. And I'm going to connect my line in between. So if we want to do that visual method, I'm going to draw a line over and another line down. And see that my distance of my pink line here is 2. So the middle is going to be at 1. And the distance of my orange line is 1, 2, 3, 4, 5. So my middle is going to be at 5 divided by 2, 1, 2, 2.5. So that puts my midpoint right here. So if we want to estimate it, since I went over 2.5, so this is at the 0.5, I know that my x-coordinate is 0.5. And then I need to move up, and I see that my y-coordinate is right here at 4. But since we had to estimate it with 5 and see that 5 divided by 2 gives us 0.5, let's check it with the midpoint formula. So I'm going to go ahead and use my 2 coordinates. So my x value is -2 plus my other x value is 3 divided by 2, comma, my y value 3, and my other y coordinate 5 divided by 2. So -2 plus 3 gives me 1 over 2, comma, 3 plus 5 gives me 8 over 2. And then if I simplify that, 1 divided by 2, if you want to make that a decimal, is 0.5, and 8 divided by 2 is 4. So I see that this estimation, not quite an estimation, but just using a visual method, it does work, but you do just need to be very careful if there are decimals with it. The formula is always a good method to check your work, or if you'd rather just use the formula, that's what you can do. All right, thank you guys for following along. We are now going to move to the rest of this in class. So for the future, you are always welcome to do the rest of these examples for homework, but it is expected that we will do these together in class the next day, so you do not need to do these now if you do not want to, but if you want the extra practice, go ahead and go for it. Thanks, guys.